we shall use our knowledge of the vectors that we have from the O-level, from our O-level class, from senior 3 and senior 2 and so on. So all of it is combined to bring us now to the vectors that we have to discuss. Our lesson actually today is all that simple vector that will connect us, that we shall later on join to have the vector that we need to have. I don't know whether these, can you see my screen?
Yes.
Yes, sir. You can see.
Are those letters visible, or I make them slightly bigger?
Make them slightly bigger.
Slightly bigger.
Okay.
Slightly bigger.
Okay.
Yes, it is clear.
Okay. We can look at our definition of a vector. We are not starting from scratch. We all have met vectors and we have an idea of what vectors are. Unfortunately, you're already seeing from my screen, but still we can share what you think as we also look at what I thought about. What is a vector? What do you know about vectors? What do you define take vectors to be? Okay, I want to hear from you. What is a vector? Anyone to share the idea that you have? What is a vector? Yes, Patrick.
So a vector is an object which has both magnitude and direction.
Okay, thank you very much. I hope you're not reading from here.
Yes, sir.
Can I hear someone else wanted to give us their view? Can you give your view in your words? Someone else was talking to us about what a vector is. It's a quantity, like you have put it, it's a quantity that is defined completely by stating both the magnitude and the direction. So both are very important if we are to talk about a vector. You will notice that I said geometrically we can picture a vector as a directed line segment. So when you look at a directed line segment, our interest here is if I have a line, if I have a line here, and it is, so if this is our line segment, can you see my screen?
Yes, teacher.
Yes, sir.
What can you see?
We are seeing a line in the arrow.
Thank you very much. So this is the line segment from point A to point B. Then we can represent this as the vector AB, and we can write this vector AB to be, we can write it as AB with that arrow, or sometimes we write it as AB with a tilde to say that this is a vector. Very many times we use small letters to represent vectors, and we can write vector A, that our AB is a vector A, and with a tilde there. So this direction AB is giving us the direction when we are writing. When I write AB with this arrow, I'm giving the direction that the vector is moving from point A to point B, and that is its direction. Then this length of this vector from here, from the point A to the point B, that length there is giving us our magnitude for that vector. From point A to point B is the magnitude. When we are denoting the magnitude, we write it as the magnitude of a vector is denoted as magnitude of vector AB, all the magnitude of the vector A. So if I am talking about that magnitude is the length of this radius vector or this line segment from point A to point B. That is what we refer to as the, or that is what our magnitude for the vector is. Sometimes we use the word magnitude or modulus. Sometimes we use modulus for that, but it is that length. For vectors, the common word is the magnitude, and it is that length that we are looking at in this case. What else can we say? What we can say here is that if a person is moving, and suppose someone is moving, if someone is moving from one point, say point A, going to B as we saw that, then again from B, I go to, again from B, if I go to, so suppose someone moves from point A and goes to point B, and then from point B, you move to point C. Under the ordinary, you have moved the whole distance AB plus BC. And I want to say that if this was to be 20 kilometers, and maybe BC is 15 kilometers, then it would mean that the whole distance that you have moved, the person has moved it from A to B up to C is 35 kilometers. However, we notice from these positions that from A, this position here, to C, that distance, the direct distance is not 50 kilometers. But a person who has moved from A to point B to point C is moving a distance of 35, sorry, did I say 50? 35 kilometers. So from A to B is 20 kilometers, from B to C is 15 kilometers, making it 35. Yet when a person moves from A to C, from A to C directly, you don't move a distance of 35 kilometers. That distance is shorter if our diagram is remain the way it is. But we are looking at those two are vectorically equivalent. And we write that actually, when I move from A to B, when I have vector AB and then vector BC, together, these two are supposed to give me the vector AC. So those are equivalent vectors. Our interest in this vector is that the starting point was A and the end point is C. And whether you take the distance from A to B and then B to C, or whether you go direct, you are having the same initial position and the same final position. You started from the same point and you're ending up at the same point. So that is, someone wants to find out, this is paper 1, yes, it is paper 1. Okay. So we have seen that when quantities involve both the magnitude and the direction, those quantities are vector quantities. What happens if the quantity does not involve both? What do we refer to as the quantity that involves just the magnitude? What do we call it? The quantity which involves just the magnitude, what do we call it? Yes, Rama?
Quantity.
Did I hear Clovis? May I hear from Rama?
Teacher, is called a scalar.
That then is a scalar. So we have vector and we have the scalar. So for the scalar, our interest is simply Jacob, may I request you to mute? Okay. My interest here is for the scalar, we are only interested in the magnitude, and yet for the vector, we are interested in both the magnitude and the direction. Now, I want you to give me an idea of what equal vectors are. What are equal vectors? When do we say that the vectors are equal? Someone to guide us, what are equal vectors? When are vectors equal? When do we say now vectors are equal? Any trial? Are you there?
I think when they are collinear.
Clovis, before you go ahead, can you hear me?
Yes, sir.
It is very good manners. It is very good manners for you to put up a hand. It is discipline.
Okay, sir,
today, this time, please go
correct.
ahead. Go ahead. Next time, to put up the hand. Clovis, please, you're on floor.
I think when they are in collinear, when they are collinear.
Okay, that is your idea. The vectors are equal when they are collinear. It's an attempt. Sima, Patience? Sima? Did we lose Sima? May I have Diana?
Two vectors are equal if they have the same magnitude and direction.
Thank you very much. Two vectors are equal if they have the same magnitude and direction, or if they are both acting in the same direction and they have equal magnitudes. That's when we say that the vectors are equal. Thank you. And then can someone then talk about when vectors are parallel? What happens when vectors are parallel? What are parallel vectors? when do we say vectors are parallel? What are parallel vectors? I have a trial. Someone is saying, I think when they are acting in the same direction. Thank you for that trial. And I have hands up now. May I hear from these hands up? And Wire is lost. Richard. Richard?
They don't meet at any point.
Someone said same direction. Now another one is saying when they don't meet. Isaac?
When they have the same scalar multiple.
Come again?
When the two vectors have the same scalar multiple.
Can you explain what you mean by the same scalar multiple?
Like when one vector is a multiple of the other.
Okay, I think that is better than the first one. Same scalar multiple. That is better. When one vector, Rama? Rama, are you there? Okay. We can then continue with what we got from, yes, Jacob? Okay, Rama, if you are going ahead, please. I'm confusing you. You are also confusing me. Okay, Jacob.
When they are in the same direction, having multiples of the same scalar.
Multiples of the same scalar. Rama? Rama, we lost you again.
I was trying to say that. Hello, teacher?
I can hear you now. We can hear you.
Okay, when you have two vectors and one is expressed as a scalar of the other. For example, teacher, when we have maybe vector A and vector B, then
let me wait a little.
Vector A is equal maybe to 2 vector B.
If you have vector A and vector A is equal to twice vector B, then you can conclude that A and B are what?
Are parallel.
A and B are parallel. Thank you very much for that explanation. That's what we were given by someone. Do I still remember the name? That if the vector can be expressed as a scalar product, one vector can be expressed as a scalar product of the other. You will find books writing A equal to lambda B, where lambda is a scalar. This scalar can take on any value, like she has given us the 2 here. So this scalar can take on, this scalar can take on the value 2. It can also take on the value 5, a half, a third, etc. The values can even be negative. The scalars could have negative values, in which case it would mean that the vectors are parallel but are in opposite directions. It is also possible to be parallel and opposite. Even when we had equal vectors, they could be equal and opposite. If they are equal and opposite, then they are parallel, but they are equal in magnitude, parallel, but one is acting in a direction opposite to the other. That is equal and opposite. Okay, that is parallel. I want us to look at a very simple example of what we already know. a very simple example of what we already know. Unfortunately, I haven't typed this out. I think I can, what do I do? Let's see how to share this. I want us to have a very simple example of what we already know. I'm looking at, allow me to take this diagram here. This is my diagram. Don't have any here. Okay, suppose I have a paragram. Suppose I have a paragram. So if I had a paragram and this side here is parallel to the side here, and equally these ones are parallel. You will forgive my diagram, but I think the idea is there. Okay, take this to be a paragram OABC. This is our O, this is our A, this is our B, and this is our C. So suppose I have a paragram OABC. So what happens if I have the paragram OABC? Let us take the vector OA to be vector A. Take the vector OA to be vector A. And take the vector OC to be vector C. Okay? So I'm having my A here, and I'm having my vector C there. Okay, can we answer these simple questions? Please, the first one being, what is the vector CB? What is the vector CB? Of course, in terms of vectors A and B, you are expressing our vectors in terms of vectors A and B, A and C. What is vector CB? If this is a paragram, that's vector CB. May I request Zoom user to rename? Please rename. I'm finding it a little challenging. Can you please rename? Tap on your name and put your name. Zoom user, please rename. Okay. Mercy, Ruth Mercy, what is the vector CB?
Okay, just a trial. I think CB would be OA minus OC or A minus C.
OA, what did you say?
In terms of A and C, I think CB would be that small A minus the small c.
Minus the small c. Can you explain how you come up with A minus C?
Okay, since like, you know, it's a parallelogram, meaning these sides are parallel and they are equal.
Yeah.
So the OA is equal to CB, meaning that OA is, since now like OA is A, small a, meaning given CB would be small a, then I really don't know how to explain it well, but that's what I could give.
Are you listening to yourself? I would wish that you would, how I wish you would, you listened, because you are stating exactly what I want. Musa?
Yes, what I think, CB, it is OA minus OC. To me, that's what I think.
CB is OA minus
OA
what?
minus OC.
Minus OB. Like that. I don't know whether you can explain that. I have Rina. Rina is giving me CB as OB minus OC. Thank you very much, Rina. I have, who is this one here? Joelia Zawa giving me vector A, thank you. I have Rina again saying CB is OB. CB is OB. Thank you, Rina. I don't know how you get there. Maybe that is why you modified it to OB minus OC. Okay, I think we take the last one since it was that. Okay, can I have Patience? Patience? Patience, are you there? Okay, may I have Alan Mages?
For me, I think.
Yes.
CB equals to CO.
Yes.
Plus OA.
Yes.
Plus AB. But then you realize that CO equals to negative vector C.
Yes.
And then AB is a positive vector C.
Yes.
So when you add that, then you add vector A, which leaves us with the answer being CB equals to vector A.
Thank you, Alan. Thank you, Alan. May I have Isaac?
Yes, teacher, having the idea that in a parallelogram, two opposite sides are equal. Meaning side CB is equal to side OA. And the vector CB
side
is equal to
CB is equal to side
CB
OA.
Yes.
And is vector CB
is equal to vector A.
Is equal to vector OA.
Yes.
Which is equal to?
Vector A.
Vector A. I want to take it to take it from there. I don't. You'll excuse me. The rest will continue. The side CB and the side OA are equal. Alan, if you check Alan's work, Alan, if you check yourself, you are also using that knowledge, because you told us that AB is equal to OC. So you are taking a longer route, Alan. When you say start from C, go to O, go to A, and go to B, it's correct, but it's longer. I would want you to notice from what we have just discussed, when a vector is equal, they are equal if they are in the same direction and of equal magnitude. CB and OA for a parallelogram are equal in magnitude. and they are acting in the same direction. And so those two vectors are equal. Thank you very much, Alan. Thank you very much, Isaac, and the rest of the team. I had other people. Thank you. Okay, we are using our knowledge, what we have just discussed, equal vectors. And I think that is very good. Go ahead and tell me what the vector BC would be. What is vector BC? Sorry. What is vector BC? What is it equal to? Yes. May I have, I don't know, Sima, whether you are there this time? Sima? Are you there? Let me take Enoch. What is vector BC?
Thank you so much, Mr. Kajimu. If we look at BC, we have said that they are parallel with AO, right? So
Yes.
it is of the vector of AO, which is negative A.
Enoch, you are saying BC equals to vector negative A because it is equal to AO, and because it is actually, you can actually also pick it from here. You can also pick it from this one here. CB and then BC. BC is just moving now backwards from B to C. So if CB is A, then it is also clear from there. If CB is A, it is also clear from there that if CB is A, it is clear from there that BC is the negative of that one. Thank you very much, Sima and Nambafu. Those in the messages. I am receiving those messages, and there are also, I think, other people. Good. I like that. Can we move on to another? I want you to give me, what do we have? Allow me to write my C here. My C here. Can we get the vector AB now? Vector AB. What is it? Yes, I can see hands shooting up. Ruth, Mercy.
AB being parallel to OC, it means they are equal. So AB is.
Did I hear that last part, Mercy? AB is?
Small c.
Is vector C. Thank you very much. They are equal and they are parallel. So they are the same. I like that. Now move on. I want to define D. I want to define D. The vector, the point D lies on AB. The point D lies on AB. So somewhere we have a point D. A point D lies on AB. That is our D. And it is such that AD to DB equals to 1 to 2. AD to DB equals to 1 to 2. I don't know whether they want me to write my 1 and 2 there, 1 to 2. We are recalling. We are picking it from the vectors that we know from our O-level work. Okay, can I now ask for the vector AD? What is the vector AD? Can I have someone to give me the vector AD? what is the vector AD? Okay. Do I have people ready? Anthony? Anthony, are you there?
Hello. Am I heard? Vector AD is as if 1/3.
Vector AD, sorry for that. Vector AD, sorry about that. Okay,
Vector
come again.
Vector AD is 1/3 vector C, small c.
Vector AD is 1/3. Where are you getting those values? Small c. Yes.
We see that AB is vector small c.
Very good. We see that AB is small c, is vector C.
So to get our AD, we have the ratio given. So we pick the ratio of AD, then we put on the total ratio that makes our
we are having
AB.
the ratio AD, which is 1 out of the total ratio, which makes up the whole AB.
Then we multiply by what is presented by AB.
That is times the AB. Thank you very much. That gives us the third of AB, and AB is C, a third of C. Beautiful. Beautiful.
Welcome.
Okay, now I'm moving on. Is there anyone who has a different idea? But I think if you had a different idea, you can now synchronize. You can now organize your idea. May I now ask for OD? What is vector OD? What is vector OD, please? What is Musa? Are you there? Musa? Is Musa there? I think I lost Musa. Enoch?
Jim, we see that from to D, from OD, we move from OA, AD.
Okay,
so
come again. Our OD is equal to
OA plus AD.
Together with
AD.
Good.
Our OA is vector A.
Our OA is vector A
plus a third.
And our AD is a third. I'm still listening. Class. Enoch. I think I've lost Enoch. Joshua, can we complete this?
Yeah. Then you add a third C.
Then we add a third C because our AD was a third C. Thank you very much. So the OD becomes the A plus a third C. Beautiful. Beautiful. Okay. Can I now have finally the vector DC? Can I have the vector DC? Can I have the vector DC? I'm still waiting for some hands up.
VB is 2 of C plus problems.
Okay, can we move on? May I have Trevor? Trevor?
Okay, Mr. Am I heard?
Yes, we can hear you.
May I think DC is 2/3 C minus vector A.
So we are moving from D, sorry, to C. Can you guide us? Where are we starting from and passing where and ending up where?
We are passing from D to B.
We are going D to B.
Then from B to C.
Then B to C. Thank you. Beyond that, what did you say?
And then from D to B, that is 2/3 C.
How do you get to 2/3? 2/3 C.
Okay, from D to B, that is 2. And the total ratio is 3.
Beautiful. From D to B is 2 out of the total ratio, which is 3, and it is in the direction of AB. Go ahead.
Yeah. And then the way I got the C is that A and B and OC, they are equal and parallel. That's how I got the C.
Yes.
Then now from B to C.
Yeah.
And O and OA,
yes,
both of them are also equal. But then from B to C, it is going in the negative direction. That's why I said minus vector A.
Minus vector A. Thank you, Trevor. Except if there is a question, I think it is clear. I want to think that Trevor is there. Thank you, Trevor. Okay. Good. I can see iPhone, please rename Clovis. I see 2/3 is C minus A. And I think there are other people in the messages. I see Queen Patricia, Vomilia, Viola, Nambafu. Nambafu, please check the directions. Nambafu has A minus 2/3 C. Please check the directions. 2/3 C minus A, Crispus, and also other people there. KTM Jordan, Wowuya, Emmanuel, and I think Emmanuel is for something else. Okay, sad. Okay, I think up to there, that is where we are. Thank you very much. So that is helping us to recap, to check ourselves with our vectors being parallel and our vectors being equal. I want us to move a little and discuss a little bit of non-parallel vectors. What do I want to say when vectors are non-parallel? If two vectors are not parallel, what would I want to say about that? When we have two vectors that are not parallel, what should I say about that? If two vectors are not parallel. If two vectors are not parallel, I suppose I have vector A and vector A is not parallel. Want to cross out the not to the parallel. Vector A is not parallel to vector B. What is it? And that those two are not parallel, but it is not only that. And that alpha lambda A plus mu B equals to alpha A plus beta B. If lambda A plus mu B is alpha A plus beta B, what can you say about the scalars? If the two vectors A and B are not parallel, and lambda A plus mu B equals to alpha A plus beta B, what can you say about the scalars? Lambda, mu, alpha, and beta. Lambda, mu, alpha, and beta are scalars. These are scalars. What can you say about these scalars? Can I hear from you? Martha, please mute. What can you say about the scalars? If the vectors A and P are not parallel, A and B are not parallel, and lambda A plus mu B equals to alpha A plus beta B, alpha is a scalar, beta is a scalar, lambda is a scalar, mu is a scalar. What can you say about the scalars? Yes, please. Okay, can I have trials, Anthony? Anthony, can you give it a shot? What can you say about the scalars, lambda, mu, alpha, beta? Yes, Anthony.
Yeah, I see that. I see the coefficients of vector A and B, the corresponding coefficients must be equal, like lambda must be equal to alpha, then beta.
Very, very good. Alpha and lambda are equal, and likewise.
And likewise, beta and mu.
Beta and mu are also equal. So for two non-parallel vectors A and B, if lambda A plus mu B is alpha A plus beta B, our interest here is that if the vectors are not parallel, then the components for two vectors that are equal, the components must be equal. I'm looking at component A and component B. So the components must be equal. So alpha A and lambda A are equal, meaning the scalars will be equal. Scalar lambda is equal to scalar alpha. Mu B and beta B, meaning scalar mu and scalar beta are equal. That is very, very important when we have vectors that are not parallel. And I want us to use an example here to help us understand this a little bit. Can I have an example to help us understand this? Yes, I think I can get an example. my example here, if I have my parallelogram that we had originally, so I'm looking at, we had a parallelogram. Looking at, we had this parallelogram here. So this was our okay. This was our O A BC. And then we had a D. I'm going to change our D this time and put our D here. This is our D. Such that AD to DB this time, AD to DB equals to 2 to 1. So this time AD to DB is 2 to 1. Now OD is produced. So I want to come again and continue here. Sorry about that. I want to come again and continue here. Let's take me. So that I have OD is produced. Producing it is making it longer. And then to meet CB, and it is meeting CB produced also at E. So this is my point, sorry. It's my point E here. This is my E. Okay, now I am there. Should I ask the questions? Yes. Suppose we are given DE as HOD. We are given DE as HOD. And we are given BE as KCB. We are given BE as KCB. This is just the idea that we already know. DE and OD are parallel. They're in the same direction. And so one can be expressed as a scalar product of the other. So that is why you are seeing DE is an HOD. And in the same way, BE and CP are in the same direction. We can say they are parallel. And the BE can be expressed as a scalar product of CB. That's what we have just learned from parallel vectors, when two vectors are parallel. And so here we are saying, write the vector BE in terms of A and K. I think that is direct. Write the vector BE in terms of the vector A and the scalar K. That's our first question. And we go through that very fast. Write the vector BE in terms of the vector A and the scalar K. Do I still have members, participants in my class?
Yeah.
Good. Can we try? What is BE? Crispus. Crispus? Crispus, would you wish to try? What is BE? Clovis? Okay, let me go to the bottom of our list. May I have Simon? Simon, can you try, please? Timo? Okay, let me go with the Mercy. What is the vector BE?
Okay, according to my thinking, BE is KA.
Thank you very much. This is, I think, direct. We have been given this to be K of CB, and our CB is A, isn't it? So this is KA. Oh, maybe I didn't tell you that we had the same vectors. Maybe some people are still wondering. Sorry about that. This is our A, and this here is our C. Okay, so this is our vector C, and this is our vector A. And so CB is a vector A. We have already seen that. And so our BE is KCB. Thank you very much, Nawile. Can I have DE in terms of H, A, and C? Can I have DE? My vector of interest is the vector DE. What is DE? In terms of H, in terms of vector A, and also vector C. Very good. Someone ready? I can see some 2 people, 3 people. Ready? I'm just waiting for you. I can see 4 now. 4 now. Ready? 5, 6. Thank you. Thank you. Thank you very much. Can I see 7? Yes, I can see 7, 8. I've lost someone already. Okay, no problem. Back to 7. Okay, let me go with starting from Tony. With Tony. Tony, please give us your thinking.
Sir, for me, I think that it is
Tony, you are on the floor. Please don't mute. Unmute and say what you wanted to say. What you think is what we want. What do you think?
Sir, for me, I think that it is HOD.
It is already given to us as HOD.
Yes.
Yes, true. It is HOD given to us there. Okay, can we add it to that? Tony seems to want it up to that point. Alan?
Thank you very much, sir. For me, I think it is H into, I'm continuing from where Tony has stopped.
Exactly, thank you.
Yeah, so it is H into OA.
Into OA.
Plus
plus AD. Very good.
Yes. And then we have
OA plus AD.
Yeah, and
yes,
then
where should I write? Just a minute. Let me get somewhere to write. Let me get somewhere to write. Go ahead.
Yeah, then H into.
This is H into.
OA is A.
OA is A. Unfortunately, I've covered my diagram.
And then
What
that is
AD?
AD is 2 out of 3, two-thirds. Because of the ratio.
The ratio is 2 to 1. True, false?
The ratio is 2 to 1, and the total
was,
ratio is 3.
DB, AD to DB, yes, it is 2 to 1.
Yes.
Okay,
and the
go
total
ahead.
ratio is 3, so giving that 2 out of 3.
2 out of 3.
C.
Of C, because AD is in the direction of C.
Yeah.
Very
so
good.
That is it.
Very, very good. Thank you very much, Alan. That is so wonderful. So in terms of H, A, and C, scalar H, vectors A and C, the vector DE is equal to H into A plus 2/3. If we have somewhere where it's not clear, please do not keep it. Let's share it at this point. Okay, do I have any question on this particular part where we are? I don't want you to give me any question and then you start asking me about Manu, about vectors where we are. Not Manu, not any, as in broad as any. Okay, if we have no issue, then can we continue? And I want us to check this matter. Martha, next time you use a hand up, but I still want to know what you want to say. Go ahead.
Excuse me, sir.
You are already excused. Yes.
I did with H and K.
Come again. Martha, network is not so clear. Is there anybody who got Martha? Do we have someone? Yes.
I think Martha is asking where we got the H and K from.
She's asking for where we got H and K. Noella, is Alan representing your view? Noella,
yes,
you had some? Is it the same? Huh?
Yes, I think she was asking that.
Where H and K come from? Okay, guide her. Where do they come from? Where is H coming from? Where is K coming from? Anthony.
Yeah, actually, H and K, they have given you such that to help you ease up with the expressions. And the question is given the question such that you can find the value of
Martha, if you check properly, Martha.
Of BE in terms of CB, then of DE in terms of OD.
Martha, we were given DE, and we were also given BE in terms of, we were given DE, and we were also given, those were given to us. However, we still explained where they came from, because we said, sorry about that, my battery was threatening. We said that DE and OD are parallel. And we agreed that when vectors are parallel, one can be expressed as a scalar product of the other. So it is very okay to say dE is H times OD, where H is a scalar, any scalar of your choice. This particular question has chosen H and has given us H. So we can explain the way that H is, where the dE is coming from equal to H or D. In the same way, BE is KCB because BE and CB are parallel, and one can be expressed as a scalar product of the other. I don't know whether that helps you, Martha. It is given, but we can still explain why, where the question got it from.
I think I've got it.
You get it. Thank you. Thank you for that feedback. Okay, now I want to ask a question, and this is our interest. Non-parallel vectors. Can you use the information that we have to find the values of H and K? Can you use what we have to find the values of H and K? What is H and what is K? Anyone ready to give it a shot? Where is H coming from? Where are we going to get H from? How are we going to get H? Where is the Caroline? They were given in the question. Someone is asking for where they are coming from. I think they have been answered. Okay, thank you. All those who answered what you answered in the chat. Can we now move on? What is the value of H and what is the value of K? How can we get those values? Someone guide us. How can we get the values? The value of H and the value of K? Musa? Musa, are you there?
Yes, yes. Okay, like from that expression, which is DE, DE equaling to I was saying from that expression, which is DE equaling to H, H or D. We can also say that DE is the same as DB plus BE. Then we get DB.
So you are saying that DE
DE, which is equal to H,
is H or D or what?
Or D.
Or D.
Yeah.
But at the same time,
the DE
is also equal to
DB plus
DB
plus BE.
Plus BE. Thank you very much. That's great.
Okay.
What makes it great is the connection of DE and the BE, which we already have. So Musa is connecting DE and the BE, which we already have. Go ahead, Musa.
Then from there we can get the DB. We can substitute for OD.
We already have HOD here in our work. It's on this page,
Yes.
isn't it?
Yes.
It is HOD, and it is the A plus 2/3 C. And we are saying what is DB?
You can also get. You can get it from
the picture. What is DB?
That is
our
1
D
over
is
3.
there, our B is there. What is DB?
It is 1 over 3 of.
It is 1 over 3 of AB, isn't it?
Yes.
And that is what?
1 over 3 of vector C.
1 over 3 of vector C. Hope everyone can see that. That DB is 1/3 of vector C. That's 1/3 of vector C. And here we are adding it to BE. And what is our BE?
We got the B in the expression there.
We already have the BE as a KA. Has everybody taken note of the BE? We already have the BE as KA. Thank you. Thank you.
Okay.
Now we can go ahead. May I ask someone to continue from there? Anthony?
Yeah, from there we open the brackets.
We can open the brackets. Please open.
We'll have H vector A.
H vector A.
Plus 2 over 3 H
plus 2/3
vector C. H vector C.
Vector C. And this is
the same as a third vector C. Is the same as third vector C plus K vector A. So now there we can use the other property we used at first, where the scalars, the coefficients of A and vector C must be equal. The one of one side must be equal to the one of the other side.
When two vectors are equal and the A and C are not parallel, then the components are equal. Thank you very much. So what does this imply to us? Can you give me what this implies? What is it? Our H.
This implies our H is equals to K.
To K. That's one relationship that
the
we
second
are getting
relationship
from the fact we are getting this from the fact that HA and the KA are supposed to be equal. So we get H equals to K. And then what is our second relation?
The second relation is that
Okay, our network 2/3 H is equal to
a third.
To a third. Is the second relation. Where is it coming from? It is coming from the fact that is coming from the fact that equal. So equating the components of the vector C and equating the components of A, the vectors A, we come up with those two equations. I fear to mention loud here that these are simultaneous because I don't want the younger people to hear that at this stage, you are doing simultaneous equations. They may think that you are not serious. Okay, go ahead and work them out. From equation 2, we can get the value of H. And once we get the value of H, equation 1 is already telling us the value of h and the value of k are very related. Give me the value of h from equation 2.
The value of h half.
Can I hear from someone else, Anthony? Give me a chance to hear from Alan.
The value of h is a half.
The value of h is a half. Thank you, Alan. May I get someone else to give me the value of k? What is the value of k? I don't know who Ara is, but Ara, please go ahead. Next time we rename. I will not work with you if you're Ara. What's the value of k, Ara?
K is a half.
K is also a half. Can we know your name, please? Okay. Ruth, did you have something to say?
No.
Are you comfortable? Ruth, you have unmuted. That's why I'm asking you. Okay, now you can mute if you are comfortable. Emerson?
Master, please pardon me on that law you have used.
The rule that we are using, we are saying when we have, what did we say? When two vectors are equal and they are not parallel. If we are having, we wrote it, if I write it the way we wrote it then, what did we write that time? We actually wrote, before I go there, let me thank Queen Patricia, Rogers, Tiwaje, KTM, Rogers again, and Violet. Thank you very much for those answers, the values of H and C that you're giving to us. Okay, then I can say we wrote it as, if I have, that time I used the lambda A plus mu B equal to alpha A plus beta B. If those two vectors are equal, and yet vector A is not parallel to vector C, it is B, not C. If the first statement, lambda A plus mu B is equal to alpha A plus beta B, and yet the vectors A and B are not parallel, then it goes without mention that these two are equal, and likewise, those two are equal. So the components of A are equal, the components B are equal. The components A are equal and the components B are equal. And that gives us the fact that lambda A is alpha A, meaning alpha. The A's are equal, meaning alpha, lambda and alpha equal. And the B's are also equal, meaning implying that mu and beta are also equal. Rina, do you have something to add? Please go ahead, Rina. Okay, if Rina has nothing to say, I don't know whether that answers the question of the gentleman. Who was it? I don't even remember. Sorry. Does it answer your question? I hope it does.
Sir.
Okay,
yes, sir.
Thank you for that feedback. Okay, so it is from that we said, since the vectors A here and this A here and the C are not parallel, then we took the A's here to be equal, and that's where we got H equivalent to K, And we also took the C's to be equal, and we got what did we get? We got the 2/3h equal to their third. The C's are equal. And when we worked out those two equations, we got the values of h and k. And that is what we wanted. Thank you. May I say something about position vectors? What is a position vector? What is a position vector? I wanted to check how far we have gone. Can we use the last minutes very carefully? What is position vector? Or someone asked, how is DE equal to HOD and also equal to DE plus BE? I think you got it, you missed a small part there. It is true that DE equals to HOD. This was given to us. This was given to us in the question. Okay, someone has unmuted. And this Ruth is unmuting all the time. I don't know why. Ruth, please take note. If you have nothing to say, do not unmute. Keep mute. Okay. And we say the same DE is not DE. Again, you have said the DE, no? DE is not DE. But if you check our diagram, it is DB plus BE. I hope that is not Rita again, is Ruth? Okay, this is DB plus BE. That is our usual vector. Please go to the diagram and connect. Go to the diagram and connect. What is the from D to E is this one. It is the same as from D to B, and then from B to E. That is what we quoted then. And I think you can always get that. So I don't know whether, Trevor, you are comfortable there? Yes, I can see Diana answering the part that DE is the HOD is from the question. The other part is from the diagram, and both are giving DE in different ways. Thank you, Diana. They are giving DE in different ways, and we are using the different ways to connect and get the values that we were looking for. Thank you. Thank you. Thank you. Okay. I was here saying, can we now share a little bit about position vectors? What is a position vector? What is a position vector? What is position vector? Can someone tell us what they think about a position vector? What is a position vector? What are position vectors? Yes. Anyone who wants to try out what position vectors, what you think position vectors are? Oh, direction vector. Thank you. That is AG. AG, I don't know where that name is. AG always. Thank you. Direction of vector. Any other trial? Vectors from the origin. That says, who is that one? Vectors from the origin is Gladys is saying any displacement from the origin to a given point. I think those are beautiful values. They are beautiful attempts. Any other? I think we can go with that. We can go with that. So position vectors are vectors describing the position of a point from the origin. A vector from the origin, position of a point from the origin. I see Nabu Kenya also saying so. So those are what we call position vectors. So if I have an origin, as in I was starting the usual from the Cartesian axis, this is the O, and I now have a point P. The position vector is that distance from O to P. That is our position vector of the point P. So this is my x-axis, this is my y-axis. I'm saying OP is the position vector of the point P. Okay? Continue. We can give it, of course, as if P is the point XY, then I can state the position vector of P as the column vector XY. I can also state it. In using the unity vectors I and J. The unity vectors I and J. These are vectors parallel. I is parallel. These are vectors parallel to the x-axis and also the y-axis. So they are parallel to the x and y-axis. I is parallel to the x and J is parallel to the y. So they are parallel to the x and y axis respectively. So, and they are, it is also important to mention that they are unity vectors. They are one unit. So these are unity vectors. So I and J are unity vectors parallel to the x and y axis respectively. So when I say this is the point x, y, it means that this is x units and this is y units to give us the point x, y. So I can comfortably express this using those unity vectors I and j as this is x in the I, and this is y in the j. This is x in the I, and this is y in the j direction. So the vector xy can also be expressed as xi plus yj. But the main thing is the position vector of the point P is the vector OP. I can have other vectors. For example, I can have a vector here equal. I can have a vector there equal and parallel, equal to the vector OP. That one could be a vector equal to the vector OP, but because it is not from the origin, it is not position vector. It is also equal to XY because it is equal to the other one, or it is also equal to XI plus YJ, but it is not a position vector of point of any point there. It's not the position vector of this point. If I called that point Q, that's not the position vector. Position vector should be from the what? From the origin. So if I am interested in position vector of Q, then I should talk about from the origin to Q. The vector OQ is position vector of point Q. So when I say position vector of point Q, then it is the vector from the origin to the point Q. That becomes the vector or Q. So we can have many vectors that are equal, but it will not be very easy to have the vectors that are position vectors. So position vector should be from the origin. Good. That gives me a number of small things that we are sharing there. So can I have this example just to check your I and J? Are you there? I'm checking your I and J. Checking your I and J. I want to have an example here. This is my x-axis and this is my y-axis. And I am having a point A, for example. My point A is 3 units. So this is my point A. And it is 3 units. And it is also 4 units there. 3 on the X and 4 on the Y. This is the position vector. I'm interested in the position vector of point A. So that vector there is the position vector of point A. I want to call it vector A. Can you give me vector A as a column vector? Can you give me vector A as a column vector? Can we represent vector A as a column vector? That's what we have just seen. Vector A is the position vector of the point A. Can you represent it as a column vector? Alex Sajabi, thank you. You are not using column vector. Rina, thank you. That's not column. That one is using I and J. Okay, I can see Diana. Oh, Noella, thank you. Noella is trying column vector. Diana could be saying column vector is not easy to write. Look at Noella's answer. Sajabi, I think we are there. Can I have someone talk to us? Kribon? Kribon, are you there? Can you talk to us? Violet, thank you. Clifford, thank you. Can I have now someone talk to us? What is the vector A? Joelia is bringing in brackets. I like that. What is the vector A? Yes, Tony. Tony?
Yes, sir. It is 3I.
It is 3I.
Then downwards, right 4J.
Downwards, J. Oh, I thought I was writing plus.
Down.
So you want me to write 4J there? Thank you. Any other attempt? Vector A as a column vector. Yes, Benas, are you Benas? Benus?
Benas, Wanyala.
Yes, Wanyala.
Just write the way as my brother has just said, but you ignore the I and the J.
Thank you very much. Tony, we are not writing the I and J in the column vectors. When we represent it as a column, we are not writing the I, we are not writing the J. That is not column vector. When we write the column vector, it is 3, 4. And now you can write this again using the I and J format. Unity vectors I and J. Can someone talk to me about writing it in terms of, yes, Rina, I and J. I've already seen it in the chat, but I want to hear you mention. Rina?
3I plus 4J.
Plus 4J. Thank you very much. 3i plus 4j gives me that vector in terms of I and j. And it is the position vector, we have said, the vector starting from the origin. Thank you very much. As I wind up, I want to mention that we can add the vectors in these two formats, column and also I and j. We can add vectors, adding vectors, obtaining a combined vector, which combined vector we also call the resultant. When you add, the combined vector is also called the resultant. So we can add in I and j format, and also in column vector, addition is very easy. The same thing as subtraction, the same thing as multiplying vectors by a scalar. So if I have vectors to add, and if I have vectors to subtract, and if I have vectors to multiply by scalars and combine, it is very easy. That's where I want to wind up. I want to wind up with an example. So you will give me a minute, and then I will finally invite Mr. Dungu. Please do not drop off to talk to our class. So as I wind up, just two smaller things. We have said, can we add the vectors? And we are saying, yes, that is a direct thing. So if I have vector A to be what we have just written there, 3i plus 4j, and I have vector B to be a vector, say, 2i plus j, then I can add the two. So what is A plus B? Since this is not news, can you please go ahead and work it out? What is A and B? A plus B? Yes, Rina? Rina, did you leave the hand up, or you are attempting? You are adding. Yes, Joshua. Okay, Rina is there. I think she had network issues.
Sir.
Okay, Joshua, can you give a chance to Rina first? Rina first, then Joshua comes in. Rina, please.
A plus B is equal to 5i plus 5j.
So you will notice that we are adding the components, the I components. 3i adding the j components, 4j and also j. So we are adding those components. And Rina says we are obtaining 5i plus what? Plus 4j. Thank you very much. Can you multiply this by a scalar? I want us to multiply this by a scalar. We still have our A as a 3i plus 4j. Please multiply it by a scalar, 3i plus 4j. Multiply it by a scalar. What is 2a? It is 2 into 3i plus 4j, because that is our A. And may I get a result from this, Lawrence?
So you've made a mistake on the other part. It is 5i plus 5j.
Thank you very much for that correction. Lawrence, thank you very much for being keen. 5i plus 5j. Thank you. Okay, 5i plus 5j. Thank you, Lawrence. Okay, can we now multiply by a scalar? What is 2a? Daphne?
It is 6i plus 8j.
6i plus 8j, meaning that we are simply multiplying each of the components by the scalar. And then that means that I can go ahead. I can go ahead, therefore, and say, if I have A as the 3i that we have had, plus the 2j, then I have B as the 2i minus j. It means I can obtain the vector 3a minus 2j minus 2b. Please go ahead and work it out and post your answers here. I want the answers. I'm going to wait for you at the side of answers. Thank you. I see in the chat, Trevor, Mutambo, Clovis, Richard, Vumilia, Violet, and Lawrence correcting me there. Tony. Okay, those ones posted the previous result. Can we now go for this, please? Anyone who is ready? Rina? What do we have? This is 3. Before you reach the answer, this is 3 into?
3 into 3i
plus 2j. Beautiful.
2j minus
2 minus 2 into
2i minus j.
Thank you. 2 into 2i minus j. Anyone who is ready? Anyone who is ready to open our brackets here? Alinda Joshua, are you there? Tony? Okay, let me go with Tony.
Yes, sir. Now we shall get 9i.
9i
plus 6j.
6j.
Minus 4i.
4i.
Plus 2j.
Very good. Plus 2j. Alan, please simplify. Alan, please simplify.
We shall have 5i.
We shall have 9i minus 4i. Please, I don't need all of this, but I'm just taking it just because we should
plus
pick everybody. Plus 6j plus 2j, and Alan is giving me the final result. What is the final result?
That is 5i.
You said 5i.
Plus 8j.
Plus 8j. Thank you very much, Alan, for that. You may not have to write everything. I don't need this as such, but I wrote it just because I wanted to collect everybody. I wanted to move with all of us because some people may not notice where the 8 is coming up from straight away. And like I said, you will do the same. If our A is given to us in terms of a column vector. So if I have A that way, and I have B as my vector -2, 1, then it will mean that I can add and subtract and I can multiply by scalars. So it will be very easy for me to obtain 2A minus 3B. May I ask someone to take us through 2A minus 3B? This means we are multiplying 2 by the A, which A is what? Can I have someone to take us, please? Can I have someone different from the 2, different from the 3, someone new? May I have another, someone taking us? Oh, no different from the 4. Okay, Kribon, thank you. Kribon, open your mic. Open the mic, yes, please, go ahead. Okay, we have issues of network there with Kribon. Okay, Daphne. Let me go to Daphne. Daphne, what do we have?
Let's have
It is
2 into brackets.
2 into the 1 negative 1.
4.
Mm.
4 negative 1.
Take away
Minus
3 into
3
brackets.
into brackets. Negative 2.
1.
And 1.
May I take Rama at that point? Rama, please. Thank you, Daphne. May I take Rama? Rama, open your mic. Rama, open your mic. Okay, Rama, we lose her. May I have Rina? Rina?
8.
8.
Negative 2.
Negative 2. Alan from there? Alan from there?
It's minus.
Minus. I like that.
6.
6.
Negative 3.
Negative 3. Wow. I'm pausing a little because I want you to take note of that. What are we subtracting? Can I have someone again? What are we subtracting? If you are taking a minus, what are we subtracting? Anthony.
I'm not getting that step they went to. The last step over is supposed to be 8 negative 2 minus negative 6 3.
Negative 6. Alan, I want you to take note that if you have quoted this negative here, then you have not yet lost it. If you have that negative there, then leave it. Now the negative is not, we are taking 3 multiplied by the, negative 2 and also 3 multiplied by the positive. We are not taking negative 3 because you've left it here. If you had wanted to move that first, then you would remove it from here and leave a negative and come with a negative at this point. I am sure that is very clear. So we shall have, what did you say that we have? Negative.
We are going to have 8 negative 2 minus negative 6 3.
Because our negative has not yet, we haven't used it yet. It hasn't been effected. So we move with negative 6 and 3. Okay.
So the final answer will be 14 negative 5.
The final answer will be, where is that coming from? From
when
8
you add
plus 6 and
8
from
plus
negative
6 negative 2 minus 3.
And this gives us 14 negative 5.
Negative
Thank
5.
you. Thank you. And thank you very much. There's something that I should mention before I release you. I'm very sorry. How to get the magnitude of these vectors. How to get the magnitude of the vectors. The magnitude of a vector is the length of the radius vector, or of the line segment that is representing a particular vector. The length of the line segment representing a particular vector is the magnitude of a vector. Now, what is my point here? If I have a vector like we had our OP, which is equal to xy,
Oh, sorry. Unfortunately, teacher Henry has dropped off, but we are going to be ending at this point here our lesson. I want to thank everyone that has been able to attend up to this time. Thank you so much for sacrificing your data to attend the lesson. Thank you so much for attending. Going forward, tomorrow, Thursday and Friday, we shall have our seminar running. That is for biology and chemistry. I understand you have not yet received the chemistry questions, but they are going to come anytime. So be a bit patient, but they are going to reach you in your different WhatsApp groups. So keep waiting, you'll be able to see them. But the biology ones, they are already there in your WhatsApp groups. So please go on and have them and try out those questions. Those who want to discuss tomorrow, please make sure that you send in your work before the day ends. Okay, let me first hear from Anthony. Yes, Anthony.
Excuse me, sir.
Yes.
I would
please.
like you to first help us with the notes on the the link for the notes that we had last time at first.
Okay.
In the group.
In the group. Okay. This evening, I'm going to share all the notes. I'm going to share all the notes that we sent earlier and the ones that we sent when you were at school. This evening, I'm going to share in about 10 minutes from now. You'll start seeing most of those notes. Then the ones that you don't have seen that you want, then you will send me a WhatsApp, send me a private WhatsApp and inform me of those notes that you are not seeing, but you would love to have them. Then in those notes still that we are going to send, there will be some revision papers that some schools have done. Please, this is the opportunity to see how far your friends have gone. So you have to try them out. And then where you find challenges, please go on and ask the teachers. They will be able to help you out. Okay, yes, Alan?
Thank you very much, sir. Yeah, about the WhatsApp groups, as you've said, I'm requesting for the link. Personally, I'm not in those groups. I request for the link to join them.
Okay, let me share the link. But those who have attended the lesson, I have shared a link in the in your chat. So click there, and then you can register for today's lesson. So just click on that link, and then you shall pick up your register from that point. So let me share the link, but still I'll also go on and share them. You'll find them on the Padlet. You'll find them on the Padlet. So that is the WhatsApp group. That is the WhatsApp group. So tomorrow we shall be having, I think tomorrow is the biology seminar. Still, it will be starting at 4, going up to 6. So in case you find the room is still there is still another class, we are sorry about that. But we shall learn slowly on how to use, how to open the rooms a bit early. Okay. Yes, Joelia.
Good evening, Mr. Kaziba. Now,
Yes,
I'm only asking, is it that I'm supposed to register once? Because I've tried to register again today, but they're telling me I already registered. Is it because I registered yesterday after the math lesson?
Oh, okay. Give me minutes. Give me minutes. Okay. 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 Yeah, you registered yesterday. But give me a minute. I send another link. But those who registered yesterday, then it is okay. But now, okay, Juliet is fine. don't register again if at all it has refused. We shall use another link next time. It is okay. Thank you.
Yes, sir. Thank you.
Okay. Hope we have exhausted all the questions. Yes, Julia, your hand is still up.
Sorry, let me just lower it.
Okay. Those who wish to discuss in the math seminar is there on the weekend. Kindly go on and do the numbers. I have so far received over 15 people who have brought in their answers, who have tried and have said they want to discuss, which is a good sign. So when you are coming in for the seminar, please make sure that at least you have done most of those numbers. Make sure that you have done all the numbers, such that when your friend is discussing, you can be able to see where your mistake is. And also you can have questions to ask concerning the numbers that are going to be discussed. One assurance I want to give you that we shall be able to go around 40% of the seminar questions, and also this topic of vectors. I'm sure once our teachers have that time, next week we shall complete it. So like I told you, we shall give a lot of time to paper one, but at least if at all this holiday we can complete vectors, meaning that by the time you come back in second term, we shall have little remaining to complete the syllabus, and we shall be ready for the final exams and our mock exams. So everything we are doing it to prepare you for the final exams and also for preparing you for the mock exams. We want to see everyone excel with an A in mathematics. Otherwise, thank you so much for attending. Thank you so much for sacrificing to be here with us. Thank you so much. I want to thank Teacher Henry for the lesson he has taught us. Thank you so much, Teacher Henry, for that service.
Welcome, Mr. Kansula. I also want to thank everybody who attended. And also maybe just to add that right now you can go and now check on a vector dot products, the scalar product of vectors. And from there, we are going to move to equations of a straight line, vector equations of a straight line, that is. Then we shall go to vector equations of the plane. And I think there we shall have the real gist of our vector that we want to do. Otherwise, I thank you very much. Now from the what we have gotten, we can easily connect when we get there. Thank you, Mr. Kansula.
Thank you so much, Teacher Henry. Can we have someone to lead us in a closing prayer? Anyone to lead us in a closing prayer? Okay.
Let's humble ourselves. Dear Heavenly Father, I thank you for this day. We thank you for the session we had, Lord, for the lesson we had. We thank you for the teachers, Lord, and for the knowledge we've acquired from them, Lord. Father, Lord Jesus Christ, as we depart from this meeting, King of Kings, Lord of Lords, protect us, Lord Jehovah. Protect us, Lord, mighty King of Glory. Continue to teach us more and more through our teachers, Lord. Bless them, Lord, mighty King of Glory, for they are continuously and deliberately rendering this service to us, Lord, with no pay, Father. Father, it is you that will reward them, Jehovah. Father, bless them, Lord, mighty King of Glory, and protect them, Lord Jesus Christ. In Jesus' name we prayed.
Amen.
Thank you so much and have a good evening, everyone.